Welcome to the Architecture and Design for Society 2024-25 lecture series. So it's a recurring academic event held monthly with 1 to 2 sessions per month. This series features esteemed speakers from various design disciplines, both local and international, who share their expertise, insights, and experiences on design and research that address societal issues and contribute to the betterment of society. So participants who are architects or licensed professionals in related fields may earn continuing professional development points by registering and attending these lectures. So if you attend more than 80% of these lectures in the academic year, you will receive a certificate of completion. This certificate may be used as part of a credit bank for credit transfer when enrolling in programs at the Faculty of Architecture at Chulalongkorn University. Thank you to Nippon Paint, Decorative Coating, Suppletie, and Woodmark Co. Limited for their generous support for the event. I'd like to invite Dean Assistant Professor Sarin Subsok to officially open the event.
Hi, good evening, everyone. I'm here on behalf of our dean, who is currently in an important trip. So good evening, everyone, and it's my pleasure to welcome all of you to the Architecture and Design for Society lecture series. This platform has served as a vital space for dialogue, exchange, and critical thinking, bringing diverse voices and perspective into our academic environment. Through these lectures, we challenge conventional ideas, expand our understanding of architecture, and explore how design can engage with the society and with the complexity of the world. And today's lecture is particularly meaningful as we have Ajahn Hseng and Ajahn Stefan, our faculty members and year coordinator at INDA, to share their experience and insight into digital craft. Their contribution to both the practice and academia make them invaluable voices in architectural discourse, shaping not only the profession, but also the next generation of the designer. And we are very fortunate to have them as our teaching community, inspiring our students through their pedagogy and their wonderful work. And with this, I would like to begin the session. Also, thank you everyone for being here. Thank you, Inda, for help organizing this event. And thank you, Ajahn Tom, for being our MC for this evening. Okay, I hope you enjoy the lecture. Thank you.
Already introduced as INDA faculty members and coordinators, so Stefan Svedberg and Hseng Lintner. They are founding partners and design principals at EACR, an international architecture and design research firm, and their talk this evening is titled Digital Craft. So EACR is a design research forum that operates in the ambiguous territory between the now, the future, and the speculative. Through the exploration of emergent technological, ecological, and cultural catalysts, they piece together probable and possible worlds of tomorrow through investigations that operate on multiple scales, formats, and materialities. Stefan and Hseng graduated from architectural and spatial design programs at SciArc, Chalmers University of Technology, and Chelsea College of Art and Design. Together, they bring a background in design consultancy, technological innovation, and academic research. They have collaborated with numerous institutions and firms internationally and have developed robotic research laboratories for architecture at Chalmers and in corporate settings, R&D settings as well. Their teaching experience spans INDA, Rensselaer Polytechnic Institute, Chalmers University of Technology, CONSFAC, University of Westminster, and the National Taiwan University of Science and Technology. Through EACR, they have contributed to international research programs and received support from organizations including Fulbright, the Swedish Royal Academy of Fine Arts, the Sweden America Foundation, and Axon Johnson Foundation. Their work has been exhibited widely, including Ghent, London, Barcelona, Paris, Glasgow, Melbourne, Brisbane, and so on. Please join me in welcoming Stefan and Hseng.
Thank you so much, Tom. Thank you, Tom, for the introduction.
Yeah, thanks,
for all
Tom.
the kind words. And thank you for coming, everyone, and thank you for having us. So today's lecture is titled Digital Craft in a Post-Globalist Age, and that's our take on Architecture and Design for Society lecture series here at Chulalongkorn. And I thought we'd start with asking the question, what do we mean with digital craft? And perhaps it's, what we're thinking is perhaps it's time to drop the word digital. As much of society is directly related to the increasing sort of digitized world, and building systems that form, rationalize, and organize architecture and buildings and cities are influenced by that heavily. So, but then the question is, has that improved our built environment so far? And what about the future? And perhaps these are large questions without a straight answer. Today we would like to talk about our work in the context of craft and the digital, let's say, and how that can confront the problem of bigness and the sort of homogenizing forces of globalization. And what do we mean with bigness in this case? The term was coined by Rem Koolhaas, and he's referring to the scale and the impact of large architectural projects in contemporary urban environments. Things like bigness encompasses buildings or urban developments that are not just large in size, but also have a significant effect on the surroundings, of course, both physically and socioeconomically, and this also means that these vast developments create solitary islands so large in scale that most financing must be sourced by or from conglomerates, corporations, and governments. And these projects represent a departure from the sort of traditional notion of scale and challenges architecture to rethink their sort of approaches to design in response to the complexities of modern urbanization and the small in context of that. So, what about craft and smallness then, let's say? So we're not saying then that bigness is necessarily a bad thing, or that craft or whatever smallness then constitute is inherently good. Maybe a diplomatic way of putting it is we are once developing a taste for the infinitesimal and a fascination for the infinite. And in our work, we are trying to operate in the intersection between these two seemingly contradictory pathologies. So for us, this has become kind of a long-term conundrum, and our techniques so far involve the re-examination of how technologies and automation, digital media, and material processes can incorporate locality and cultural context through system-based approaches in relation to bigness. Sort of a bottom-up approach where small can have a direct agency over the big, let's say. But just before we begin, we just want to provide a bit of context who we are and our background. So outside of our practice, we've been working for and consulting for various companies since about 2007. We've been working mainly in large-scale projects internationally, but also with alternative construction and fabrication technologies. And in my case, outside of our own little practice, I work for Swedish, European, and US firms, including Moshe Safdie, which is maybe the most known one. And similar in Hseng's case, she has worked across Sweden, Europe, and US, and also for B+U, a Los Angeles-based firm run by Scott Urio and Herwig Baumgartner, the former Gary and Partners leads working with engineering and complex geometry and things like that. So we have always also, like Tom just said so kindly, worked in academia and parallel to practice since almost day one, since we started working. So we've done master's and bachelor programs in universities in the US and Europe. And in our own practice then, which is maybe what we are going to expand on in this lecture in the beginning, we've been working with since 2010, and we've been working as architects and consultants, mostly for the large-scale condos, malls, urban planning property developments and management of land as well, and a few occasional interiors here and there. And beyond designing, much of this work is to manage projects, and you never really know where you will end up in architecture, so to speak. So let's return to bigness, and then afterwards Hseng will take the last half and expand on craft and smallness then in the later half. So many of our larger client projects are based on client-based commissions. So far, they've been in the Southeast Asian region, much of it in Malaysia, Kuala Lumpur, Johor Bahru, as you can see in the map here. And today we're going to start by discussing 4 projects where we have to address questions surrounding bigness and the impact it may have on that particular region. And all these projects are within the vicinity of Johor Bahru. If not familiar with it, Johor Bahru is a city just north of Singapore. It's kind of what would you say, an incomplete border city a bit. It's sort of the opposite of what Singapore is, and it has been under development in recent years. It's been a long expected boost for Johor Bahru, and we happen to be caught up in that. And all the little red dots scattered on the map are projects where the project we'll talk about. The sites are clustered in neighborhoods around other developments, so there's many sites around these areas. And this sort of cross-collaborative urban planning that sort of sporadically happens is typical for much of the work we've done in Asia. So let's look at some projects. So this is one of the earlier projects we did in Malaysia. In Johor Bahru, we were asked to design a mixed-use hotel, apartment, office, mall, big complex called Lot 290. So this was a proposal in 2013. And for us, this was a milestone and very important, especially for the relationship to this client. And like all big projects of this genre, the profit margins were ruthless. And some of the questions we had to ask were, how could we subversively co-opt the market economy of the very large project to serve as a community hub? And to this end, how can programming the building create surprising agencies that intensify the architectural landscape? So the project is in the middle of Johor Bahru on the north side of the city center. The site is situated right on the main artery linking Johor and Singapore straight over the main causeway. And this is Hseng and our good friend, Mr. Hseng, on the site. Typically, we take on projects where we work directly with consultants, just like Mr. Hseng, and local management teams, and various surveyors, submitting architects, drafting companies to work on land developments and zoning, and so on and so forth, before we start a proper proposal. And this site, the land around it was permitted in a usually high build-up area, around 5 or 6 times the land, similar to what you see here in Bangkok around the BTS stations and high areas like that. The building party is composed of 3 interlocking geometries around 3 connected courtyards. And the land around here is mixed between our clients and other clients, so it obviously depends a lot on what other people do around these places. And in discussion with the local council, we proposed more commercial street fronts with shopping and pedestrian access, and we proposed more sort of green area and things like that than was required as part of the greater master plan to gain sort of perks from the approval process, which you often do. So not knowing much about the neighboring projects to come, we based our first ideas on the local street fronts rather than the towers themselves. So we wanted to propose sort of a city in a city, where the podium is deployed as an urban intensifier, incubating a culture of congestion where different functions and activities intersect and overlap. It's a big and complex project, a total build-up of almost 90,000 square meters. It comprised of over 400 hotel rooms, 400 residential units, almost 200 office units, 300 mall lots, and so on, and plus community spaces and so on. The ground and the lower volume are mainly public, with commercial lots and restaurants, hotel functions, and apartment lobby, as well as back of house and centralized hotel kitchen and things like that. The second tier volume up are split between commercial, hotel, and residential, containing office spaces, hotel function rooms, apartment, common spaces, gym, housekeeping, things like that. And the third volumes up are towers. The northernmost volume are mainly hotels, and the southern volume is apartment units. So the design volumetrically was made to offer views, spatial experiences locally and within, and as an addition to the cityscape. The project was intended to play as sort of boulders, was a play on this idea of erosion and boulders and spatial experience emulating geology and vastness, while these smaller gaps, sort of cracks against the street, would function as local smaller experiences where you can create a local and more intense environment. It was important that the project would appear as these clusters of smaller scale massings, almost leading as sort of separate volumes to form streetscape, shops, restaurants, and cafes, then literally creating a street front. It's very common around the area that everything is parking lots up to a certain level. So just in this region, we put a considerable amount of money aside in order to dig down. The exterior sun shaders are made up of 5 varying size panels, and this had a lot to do with the expression of the design, but also a certain function to it. And this is typical plans. A typical shear wall construction with a curtain wall on top and a series of apartments, mainly 1 bed, 2 beds, and 3 bed duplexes. Hotel rooms would just be typical stacks. So the project was designed to offer access to the community and around the city, and it was intended to become a node that connected neighboring sites and a beacon in the area, a place to go to socialize and for citizens among tenants. And much of the project was spent on negotiating regulations, zoning, meeting program requirements, and kind of a fight with our own preference and our own agendas for this particular project. And the next project here is called One Time Ago, and we designed it some years later in 2020. We were asked to design another apartment hotel complex. This project is quite different from the previous one. At the time, we were beginning to see changes in the market, and COVID hit. Families were looking for better and larger homes, and that became the agenda of pretty much every project overnight. This allowed us to focus more on livability and community rather than asset-driven developments to our preference. And this is located west, just up the street from the previous project, up the hill overlooking the city. While it also is a very large project, about 60,000 square meters, it is slightly smaller than the previous and more private in relation to the urban fabric. The program here is much more reduced. Instead of overlapping and intersecting the different functions and activities with the building, here it was more important to emphasize domesticity and privacy. We also needed to propose kindergartens, clinics, shops for basic goods, and plenty of social special tenants embedded in the typical commercial lots. So the project suddenly got more intertwined with society and needs. Our response was to completely separate the program from the apartments and the auxiliary programs. So although both private and semi-public programs seem to interlock volumetrically within the building, they are very much autonomous with separate amenities, separate circulation, separate entrances, separate everything pretty much. And the facade is composed of a double envelope, one outer wall with balconies and movable shaders to mitigate sun exposure to the apartments, and an inner glass wall allowing panoramic views across the city towards Singapore. This double envelope creates kind of an interstitial space between inside and outside. Large all-around balconies with planters and space for plants. These sort of interstitial spaces function both as gardens, we hoped, and as outdoor interface, sort of filter between the domestic space and the space of the city. You can see a few of the apartments here, or all the apartments pretty much. Outer walls of every apartment then has this sort of layered balcony kind of concept with a perimeter with these sort of shaders so you move back and forth. Apartments range from 1 to 4 bed units in different variations. There's duplexes and double height stores as well. This is a close-up of a bigger one, and yeah, you can kind of see the condition here. So most of the apartments were corner units as well, so we designed the development to have more of a corner condition. In some of the units, the balconies are really big, up to 22% of the total area of sort of offering direct access out. We promoted that to have this sort of buffer zone between out and inside, and create a sort of sense of privacy. So despite the large scale, we were suddenly designing homes for long-term tenants in mind and doing less parties catering mainly to transient business-related crowds and investment. And since then, discussions have been held on quality of living and life primarily, especially when it comes to housing. And how can we emphasize domesticity and privacy in this large-scale context? How can this be a market for the tenants and for living and not for only investors, or at least some kind of equalness in that balance? Do we have agency as architects to confront such market questions related to bigness? And this project is still ongoing. We're hoping to return to this later this year. This is a proposal for a semi-detached housing typology. The proposal was designed as a design sort of typology for various sites in and around JB, but it was initially proposed for a particular site, as you can see here up in the corner, and it was in the back of a golf course, sort of a service area. We'll return to this particular site in the next project. And typically, semi-detached housing is to kind of maximize land usage, kind of walled neighborhoods, and it was planned as dense as possible, of course, to stack these together in strict grids to waste as little as possible. And this version had a few suspended driveways. We tried a few ways to create more public area within these variations. Typically in JB, though, a development like these comes with a few different variations and sizes of houses. But we decided to take a chance and scrap the variations to afford more luxury and articulation in only one typology. So we needed to do less variations totally. And essentially the design is made up of a series of stacked volumes that vary the design expression. And like typical semi-detached housing, the proposal can be divided into two to host an extended family. There is a tight interplay between the build-up area and the lot size. So this is exactly on the edge of what is allowed regulatory. It is a maximum-sized house with a minimum-sized lot, you could argue. The gates and walls around each lot were to be replaced by greenery and level changes, water barriers and landscaping to kind of create a feeling of a larger lot. And to create privacy as well as shading within the setting, the glazed areas are pushed in and into these central voids in the development. To tie the materiality of the building to the area, we suggested that the facade would be clad with local limestone. Our design proposal for the facade is a series of precasted and prefabricated wall elements that features various small and large apertures, a kind of eroded porosity made from tiled grids and glazed openings. And here's a limestone quarry in the area. We wanted some kind of cheap material that would develop this sort of pattern over time as a way to create diversity in the building. We didn't want to propose a typical semi-detached house, clearly. This sort of mass-produced housing where we do a few variations and then we just catalog different materials. So instead of designing these 3-4 variant topologies, we increased repetition instead. And we also increased then formal expression, alternative to space planning, to argue for and allow for more atypical material, more expression, more luxury amenities. We introduced a floating pool and patios and things like that, which you normally don't see. This project is kind of then we argue, examining the bigness of vast repetition, suburbia, if you will, and tries to maintain quality material and architectural expression in various ways. And then to the last project in this first series here is an urban master plan called Bandar Siri Alam. This project is a redevelopment we did from a golf course, which is located on the sort of east side of Johor Bahru. This took a few years to get the land titling and the subdivision of the lots for this golf course approved. So it's a 19-hole golf course squashed into this land with a sort of hill, and whatever remaining structures on the land had to go or are being torn down as we speak. And the hill is a sort of the clubhouse on top of the hill was this sort of kind of cool high-tech Pomo style. What would you say, clubhouse and entertainment complex that was designed by a Japanese architect sometime in the early 90s. It was kind of destroyed by botched on extensions all over it, and it was decided that it had to go for much more higher planning. And in 2021, we finally got the green light to do a full proposal across the west portion of the site. This portion is about 113 acres in total. The first thing that was planned on the site was, with the authorities, was this access route you can see that crossed from one side of Johor Bahru to the other on that side. And following by these vast subdivisions of zoning and land titling. And here's our current proposal. The site is its own township with each land parcel connected by parks, green corridors, skywalks, 2 parallel avenues on each side. The main goal is to make a walkable, greener and cooler city. Some of the roads beyond the main arteries are extended to the lot edge to connect neighboring developments. And the project is humongous, at least to us. It contains 2,500 apartment units, 500 service apartments, 500 hotels, at least 60,000 square meter indoor and outdoor commercial program, sports and recreational activities, a school, elderly facilities, cultural complexes, extended public transport. There's almost 200 houses on here, 150 or so. And there is other municipal services like water treatment, electric devices, and a water retention pond as well. And this is all within this park-like setting. And it took us then a while to settle the approval process for different heights, how we could take a little from one site and put on another in terms of build-up area to create variations in the zoning. So in the end, every possible ministry and state department was involved in this project, and it was a lot of meetings to get anything running with this. And here's a view over the central pond across one of the main park stretches through the commercial and office building higher up to the northeast. And some of these ponds are there not only for aesthetical reasons, they're obviously retention ponds and reservoirs as well. The city features linked bridges so that tenants, professionals and visitors can cross over from park to park on foot, enjoying views across the neighborhood. The main street circulating the northwest side feature a more compact street front and more urban activities. Here's a view over one of the avenues with large sidewalks and urban street side architecture. Here's a view over the central park node at the threshold between the more domestic park landscape and the urban zoning here, perhaps you could call it. Indifferent from the street side, the architecture within and around the parks form private pockets and variations in the landscape. Here is a view across the reservoir that will also serve as a feature in the park in the lower end of the site, containing pavilions and function areas. And here's a view across the commercial, more urban zone with offices, leisure, culture and social functions, and a school somewhere in the back. So this project is undergoing development at the moment, and there's various bids going. And this is an attempt for us to create a pedestrian city where people could move through green areas undisturbed by traffic and promoting health and outdoor activities at the doorstep of housing and offices and so on. And a few questions we're still asking are, how can planning at this magnitude inspire the local and the small? How can texture, materiality, craft, and ornament be considered within contemporary urban planning? And what model of urban development does it take to inspire new modes of designing? So these 4 projects are all within the Greater DLP, as I mentioned earlier, and all urban projects around here, sort of, you would say, creating a new city, are all through the concept of bigness. And with that, I will hand the mic over to Hseng.
All right. Thank you, Stefan. So yeah, as we can see through our practice, we have experienced firsthand the kind of intricate relationship between bigness and asset urbanism. We have seen how the kind of neoliberal mechanisms such as capital flows, financial deregulation, market speculation, and the proliferation of real investment trusts shape the commodification of urban spaces. And in terms of architecture, one could argue that the aesthetics of this evolution has been shaped by 2 interrelated trends. Firstly, it was talked about quite extensively before, but there's a kind of homogenizing tendency of modernism, whose systems we're still using today. And secondly, the globalization and standardization of architectural practice. And so the problem with bigness is its reliance on the use of kind of mass-produced, standardized parts, and the kind of alienating scale and use of the sort of placeless materials often disconnects the built environment from local context. And so, we're also seeing that kind of currently complex global production and supply chains are only reinforcing this paradigm. And, CAD blocks and BLIM systems, they also have this kind of tendency to standardize design processes more than the global industrial supply chain already does. And so they reinforce generic architectural tropes and design languages, resulting in buildings that are completely detached from a local sense of place. And the homogenizing tendencies of the sort of modernist lineage of architecture is further kind of effectuated by its inclination to strip buildings of iconography, ornament, and all the kind of cultural symbolism that comes with it, and the kind of sensory experience that comes with it as well. And so if Rem Koolhaas's bigness is about the radical potentials of scale, where architecture becomes so large that it breaks with context, it breaks with function, and even traditional authorship, then its opposite would need to emphasize kind of contextualism, intimacy, craft. So in this regard, as mentioned earlier by Stefan, our practice operates at this sort of intersection between these 2 seemingly contradictory pathologies. So on the one hand, we're kind of actively working on a series of large corporate projects that deal with the layered complexities of urban networks where different functions, activities, desires, and interests overlap. And on the other hand, we're engaged in research-based projects, which is what I'll be discussing now, that specifically target contemporary manufacturing methods, and they concern questions of fabrication, assembly, material processes. So this is the scale of kind of detail, tactility, and touch. We don't see them as antithetical, even though they might appear to be so. The problem of the large is that it inherently requires a kind of systems-based approach, which easily slips into the generic. Our concern with fabrication is to push back. Hello? What just happened? Hello? Okay. Okay. Thank you. Sorry about that. So our concern with fabrication is to kind of push back against the generic. And our techniques involve kind of re-examining how technologies of automation, digital media, material processes, and so on can incorporate kind of locality and context through systems-based approaches. So we'll be seeing kind of the large and the small through this systems-based approach. So maybe just to clarify, when we say craft, we don't mean craft in the manner kind of pastiche, but a kind of contemporary craft. And so we see the small as a way to re-examine bigness by asking a series of questions. How can smallness play a role in resisting the homogenizing forces of globalization? How can it confront the universalizing tendencies of production in the aftermath of the Industrial Revolution and later modernism? And how can we incorporate craft as a systems-based tectonic that can be deployed across a larger scale? So, in the second part of the lecture, we will present a series of ongoing thought experiments as well as some academic research. Okay, so this first project is the log bothy series. One approach to systems-based thinking that is kind of place-specific is a re-examination of place-specific classical or even pre-classical aesthetics in architecture. This series is a kind of thought experiment looking into structures that appear to have an ambiguous place in time. The study is a kind of critical response to the current wave of nostalgia in the Swedish public imagination. So the project is based in Sweden. And currently in Sweden, there's a longing of a lost past, which is a reaction against the many new generic developments that have been built recently. And often this longing is being articulated through the desire to replicate historical styles, which I think, in our opinion, reflects a kind of extreme lack of imagination. And so this kind of replication inevitably results in this sort of aesthetics of fakeness, where we're confronted with the problematic of the copy. And in the case of imitating past styles, when we no longer use the same construction methods, buildings will always look and feel like architectural fakes. So, I mean, just for example, a classical style building built today will always have the telltale signs of contemporary construction methods. Of course, the extreme example is the kind of Venetian or Caesar's Palace in Las Vegas, which we will get back to in a bit later. And so our response was, instead of merely mimicking historical styles, we tried to explore kind of alternative narratives and forms that are suspended in time. So the idea was that these bothies would appear to be both historical and neoteric. The result is an architectural artifact that has multiple readings, we hope. And the idea is that they kind of play on the familiar, but they also estrange the familiar. The design is actually a retake on the vernacular classical Swedish Faluröd wooden cottages and barns widely found around the country. This is a typical example from a region called Dalarna, where my Swedish half of the family is from. And the image of the Faluröd cottage, hut or barn is deeply ingrained in the romanticized image of the idyllic Swedish countryside. So this is a Swedish typical bothy or wilderness hut. Again, in Idre, where my Swedish half of the family is from. It's a basic shelter, usually left unlocked and available for anyone to use free of charge. They're also for emergencies because it is quite wild in this region. And they are typically found out in remote areas in the wilderness and across country trails. And traditionally, they are constructed from intersecting logs that are shaped to overlap in the corners. Here's a kind of closer look at some of the traditional joineries and assemblies between these modules. So yeah, in terms of re-examining the construction of this through a digital lens, the log itself can be conceived as a kind of module. So what we have here are kind of a series of repeatable, standardized elements and joinery that can be assembled through multiple configurations. So this was achieved through the creation of kind of bottom-up algorithms that control a series of inputs, including the number of module lengths, the number of joint angles, which ultimately affects how many different pieces need to be manufactured, and the desired final volumes, which obviously affects the scale and the overall massing. So in this way, inputting the sort of different starting seeds can result in different outcomes. And by changing the kind of volumetric variable, it can also be deployed across multiple scales. And we also started to explore how it could be inserted or connected to other systems. So in this case, this kind of stone plinth, also typical of the Swedish barn typology. It could be attached to an existing structure, or the proposed system could also act as an extension. And while the development of this sort of systems-based approach is quite important for our process, so is representation. We see representation as a design tool in itself. It's a means through which we can kind of evaluate our design outcomes. So in this case, by putting the architectural artifact back into its vernacular context, we can really start to see how it can relate to site and expand and contract historical time through the sort of ambiguity in the reading. So what might appear to be a strange artifact of the past also presents an uncanny present. So, is it very old? Is it very new? It's not immediately clear. And so these bothies are supposed to displace the onlooker in time. And we are simultaneously caught between a retrospective past and a mysterious future. So interestingly, what started off as a thought experiment slowly developed into conversations with regional actors in Idre. The area is known primarily as a skiing destination, but is gaining popularity as a summer destination as well. So the region is home to kind of forests, marshlands, and highlands that have varying degrees of extreme remoteness. So this is Stefan and my cousin walking along a typical fell in the area. And some of the existing bothy infrastructure is actually based on old highland cattle farming traditions. So many of these existing structures are in kind of disrepair. And so now we're in the process of proposing a series of bothies, newer bothies that we plan to present to the local administration. So just for some extra context, here it's also typical to find bothies that are more embedded in the landscape. And in addition to the traditional bothies, the area is also home to the southernmost Sami population in Sweden. So there's a kind of indigenous people that live in the north. This is a typical Sami kota, which is a kind of dwelling. Nomadic dwellings are often made of wooden poles and reindeer hide. That's like their main kind of activity is to herd reindeer. And more permanent dwellings like this one are made of wooden poles, peat, and moss, and they're meant to be overgrown with time. And so drawing from these sources, we proposed a series of bothies with varying expressions based on their site context and levels of remoteness. So some are designed for marshlands, some are for highlands, which consists of fells and grasslands, and some are kind of for more forested regions. So the idea is that ones in less remote areas would be designed to stand out, whereas others in ones in more remote than less remote areas are designed to stand out, where others in like more remote areas are designed to be withdrawn. Okay, so in the previous project, we looked at vernacular materials in terms of assembly. And this next one here is another take on the rereading of cultural context and the problem of the fake. And this time we're looking at data sampling of historical architectural artifacts. So this is called Kitsch Edifice. It was a thought experiment back from 2016, and it emerged as a reaction to some of the developer work we were doing at the time. So in one meeting, I think we were actually asked if we could design, what was it? It was a mall, right?
Venice.
A Venice mall? Okay, a Venice, a mall in the style of Venice. Anyway, so this thought experiment, it was a kind of reaction to that. It's a kind of speculative urban tectonic. And through the employment of iterative photographic scanning, as well as kind of the processing of that data and processing of the imagery from that data, and kind of we use that as an alternative means of generating geometry. So the idea is that this particular project breaks away from direct computational kind of Euclidean modeling logic. So a lot of the resulting design is actually an effect of the manipulation of material behavior and of the data, rather than an effect of modeling. So the idea was that it would be kind of 3D printed in the form of a Victorian urban block. And it would be a play on the sort of mock architectural styles that are popularized by uncultivated taste. Again, think Las Vegas and architectural fakes like Caesar's Palace, the Venetian Paris, Las Vegas Hotel, and Bangkok's very own Sathorn unique tower. So in some ways, we're kind of unlearning from Las Vegas, to quote our POMO friends. And we thought, as part of the thought experiment, as building technologies evolve, new forms of architectural imitation could emerge. And so this project kind of juxtaposes this sort of kitsch Las Vegas copy design style against a disfigured Frankenstein's monster of itself. And so, the project navigates between kind of physical and digital through the deployment of techniques that intervene in the data sampling process. So we're, concerned with kind of reconstruction, but we're not concerned with the exact copy. So here, the 3D scan is like purposely incomplete. And the resulting point cloud surface reconstruction is purposely badly interpolated in these incomplete zones. And so, using a combination of these geometric distortions and toolpath manipulations, the resulting geometry is kind of further deviated and contorted through changes in speed and excess material extrusion. So in place of any kind of notions of direct translations, high fidelity copies, the project embraces the kind of digital and material entropy that occurs when data gets transferred from one medium to another. So it exploits the kind of discrepancies and gaps in the sampling and the material processes. So the project, it adopts the noisy, it adopts the incomplete, the dirty, and the imperfect in the application of techniques and aesthetics. So here, the kind of gloopy quality of bad scanning, bad mesh interpolation, bad printing becomes more desirable than their anatomically correct counterparts. And so this creates a kind of ambiguity in the reading of the architecture. It no longer exists only as a copy, but it takes on an aesthetic of its own that is familiar but yet uncanny, a kind of estranged reading of the typical Victorian block. So archaic architectural elements such as keystones and cornerstones undergo kind of multiple translations, estranging and disconnecting local figures and features from their original purpose. So what was once a kind of structural element became a kind of fake cladding detail, which you find in Las Vegas, where the keystones and cornerstones are merely masks that symbolize structure but aren't actually structure. And then here, they're kind of just a mere gesture articulated by toolpaths. And here we start to explore what happens when the system gets deployed at an urban scale. And this is a kind of city of architectural ghosts. Okay, yes. And the facade becomes merely a kind of type of mask and a series of echoes and apparitions from other places and other epochs, kind of superimposed and juxtaposed on and against one another. So here we start to explore a different take on 3D printing, this time as a kind of digital stucco or surface ornamentation. So this project has currently been done in collaboration with Chalmers and the robot lab there using the cellulose wood pulp 3D printer at the school. And the project borrows from the tradition of kind of stucco plaster reliefs from classical architecture, Baroque and Rococo. This is from the Louvre Palace in Paris. Sorry. And the project explores the potential of 3D printing toolpathing as a decorative articulation for architectural elements such as walls, ceilings, vaults, and so on. In this case, the element we are focusing on is the column. So here, the kind of regular, stratified, striated, kind of typical 3D printing lines undergo a second layer printing that is purely superficial. And this is work in progress, so we're still working on some calibration. But the idea is to print on top of a print. So what that kind of double print ornamental layer starts to do is break the kind of perceptual reading of the typical toolpath stratifications. That is one of the major tropes of 3D printing. And so when working with kind of non-desktop 3D printers, it's important to keep in mind that printing supports creates large amounts of waste. I'm going to get quite technical in some of these projects. I think it's kind of necessary. But basically, the column's base geometry was designed so that no support material would be needed for printing at all. And so this means no overhangs over 40 degrees. Here, the apertures of the columns all meet in this sort of Gothic style arch. So you'll see the kind of pointed top there. And this is to accommodate the parameters of printing without supports. So you wouldn't be able to have like a more arched Roman column, for example, because that would completely collapse. We also had to work with calibrating many elements of the extruder itself. So things that you normally take for granted with a desktop printer had to be designed into the printing algorithm for the robot. So this includes the speed of the robot arm and the feed rate of the extruder, which was based on the sort of turning screw head. We also had to stop and start the extruder, but it was a little more involved than that. So the extruder, because the material is so sticky, there was so much pressure in the extruder itself. So material was kind of constantly being pushed out, even when the extruder wasn't on. So this meant that we had to introduce and calibrate a kind of retraction. So every time we would print a path and stop, we had to get the printer to suck the material back up into itself. Between the kind of extrusion paths. Because the material is also so sticky, it's really fibrous. We also had to add this kind of, you can't see it now because it's so fast, but we had to introduce a sort of flicking motion with the robot, so it would kind of tear the top off. At the same time, so it would retract and do this flicking motion at the same time. And this would not have been necessary with a material like PLA, but because we're working with this super sticky material and it's quite a wide thickness, we have to, there was a lot of headache around that. But I think, we could probably calibrate it further. But anyway, so to achieve the kind of overprint of the digital stucco, we first had to 3D scan the print. This because the kind of slight discrepancies between the digital geometry and the physical output, they're not quite the same. So like most plastic 3D printers, the material tends to warp slightly as it cools. But this material, because it was made of wood, actually kind of absorbs moisture from the air. And so it tends to kind of swell and contract depending on the humidity, just like a real wood would. And so we had to 3D scan it just before projecting the toolpath and printing, and we had to do it kind of on the spot in the moment every time. And because of the topology of the surface, the extruder had to be kind of as close to the normal of the surface as possible, or perpendicular to the surface. Some of the surfaces were too steep for the kind of angle of approach. So you can see here it's kind of quite awkward for the robot arm in some positions. So we had to kind of compensate by tweening the approach between the kind of the surface, the normal of the surface, and then the Z direction of the robot. And so to minimize sort of potential errors and reprinting kind of large sections, the column itself was designed as a series of kind of 5 interlocking pieces that are kind of friction fit together. As mentioned earlier, this material has a tendency to warp and shrink slightly over time. So this sort of interlocking and friction fit was a way for us to kind of negate any issues with tolerance that might emerge from the material. And I think in this next project, we kind of started to ask, what if we took this one step further and only printed the ornamental toolpath without the base geometry? So here, the ornament itself could be structural and performative, and the toolpath could become a type of ornament. So here, we 3D printed 8mm PLA on a 3D CNC milled surface topology. And the toolpath design in this case had to have enough density to cover the entire surface. And joints between the surfaces needed to be designed to kind of overlap and interlock. So in this case, the seam between parts becomes part of the surface articulation as well as a structural reinforcement. So yeah, unfortunately, we have a video of the kind of test print, the first test print. Again, this was an early print, so we're just printing on a flat, we're still calibrating, so just printing on a flat bed. Okay, I think we get the point. Okay. This is also work in progress, this time working with ceramic. So one thing that we would like to try with the robot is to use the robot to paint kind of different ceramic glazes on different areas of the surface, which we haven't tried yet. But yeah, it would be nice to get that on the kind of apertures of the geometry, so openings could be highlighted. Anyway, this is just thrown in there. It's very much work in progress and has yet to be continued. So now we're going to move from our own personal research into some teaching projects as we can kind of conclude our lecture. This is from a master course at Chalmers, University of Technology from 2019. And the project was a kind of design-build studio, and it was a collaboration between Chalmers University and various industry partners. So one of these was RISE, which is the Research Institutes of Sweden, who were developing a wood pulp cellulose printer at the time. So this project actually predates the column. And a lot of what we did here ended up being used in the column. So another collaborator was a Stura Enso, who were developing wood pellets for the printer. So they were developing this sort of wood cellulose material. And basically, these pellets were made from wood pulp, which is a byproduct of the Swedish lumber industry. And then one of the other large partners was Vinnova, which is the Swedish Agency for Innovation Systems, and they provided some of the funding for this project. So Stefan and I were invited to join the teaching team in the second half when the studio was starting to fabricate. So we had to basically kind of come in, evaluate student designs, help them redesign everything because they knew nothing about the printer. Yeah. So anyway, we thought in the context of this lecture, it would be helpful and informative for you to see some kind of student work that are not from Inda or Chula. And teaching actually occupies a large part of our research. It allows us to both share our knowledge, but also open up our own kind of agendas and ideas in a context which is much more like a forum. And this means that ideas are they're not only shared, but they're kind of developed and discussed together with students, other faculty members, and industry partners within an academic context. And yeah, similar to some of the projects we presented earlier, this project also works with the material entropy and overflow, as you can see. And the project is a kind of wall section of a much larger scheme or proposal. And it's made of a kind of series of running bond blocks. And the wall plays on the kind of juxtaposition between two sides. So we have this front side that's very smooth, and then this with kind of these scooped grooves, and that's structurally supported by this lattice work on the back with varying density. And the toolpath deviation is just determined by an image sampler, so nothing too complex there. And yeah, with some of these deviations actually extend for even 40 or 50 millimeters beyond the geometry. So it starts to look like hair in some places. And the final design outcome was the result of a kind of series of calibration tests done together with the RISE team and their printer there. And we kind of explored the limits of the depositing speed, toolpath deviations, and overhangs. And at this moment in time, Chalmers didn't actually have their own printer yet. So the 3D printing was carried out at RISE. And yeah. So all the elements that were calibrated for Rococo project were designed here first. Initially, the cellulose 3D printing at RISE, they were only able to print continuous toolpaths. So this whole idea of kind of retracting the like all those calibration tests we did where we retracted the material, added the flicking. This was something that we actually helped consult Rise on with their robot extruder there. And then later on, Chalmers actually bought this extruder from Rise. And then the reason we got funding to do the other column project was so that we could calibrate the robot setup for Chalmers. So yeah, I mean, in the case of Rise, we actually had to output G-code directly from Grasshopper to the robot because ABB was also involved. I think they wanted to develop their own kind of algorithm or software for large format 3D printing using G-code. So you could just input G-code and then it would print. It would just print directly. Another exploration in robotics was carried out in a recent-ish vertical studio we taught at Rensselaer Polytechnic Institute in the US. So these are kind of third, fourth, and fifth year students. And here we worked with architectural sampling and robotic sculpting in massive materials. So I think in architecture, kind of mass is this like increasingly elusive condition. A mass usually evokes associations to much more archaic forms of architecture that are, that have kind of other modes of production that are much more old school. So you have the kind of monolithic rock-cut architecture of Nabatean mausoleums, or Indian cave temples, or the hypostyles of Egyptian halls, or the stereotomy of medieval cathedrals. By contrast, contemporary architecture is more often conceived as surfaces. So the prevalence of sheath material and use of digital software results in a kind of architectural tectonics that are determined by offsets and layers rather than by excavation and stereotomy. So indeed, the geometry of digital space is itself described through the kind of infinitely thin coordinate systems of Euclidean and topological space. And so in this studio, we revisited the notion of mass through the interrogation of computational tools for design and production and their kind of interface with contemporary massive materials. So more specifically, the studio, just for the sake of speed, we used fabrication techniques that targeted robotic carving in foam to construct a series of architectural elements such as kind of columns, entablatures, walls, arches, apertures, and so on. And these architectural system elements, were conceived as a series of modules within a larger system, much like the ornamental mass-produced capitals, keystones, cornices, and so on that adorn kind of Victorian architectural mass-produced housing facades. This is kind of early mass production that we're kind of revisiting. So the project had to tackle kind of two scales simultaneously. So the scale of the detail element and the scale of the larger assembly. So here's one example of the kind of larger scale in urban infill lot. And the system is comprised of an aggregation of kind of one column element, one arch element, and so on. And you can see this maybe more clearly in these diagrams here. It's a little bit studenty. Obviously, it's student work. Here you can see the kind of underlying structure and layout composition. And the elements are kind of aggregated into configurations depending on the kind of certain site conditions and programmatic conditions. And the detail element was conceived as a series of blocks that could be stacked using stereotomy. So the robot was used to kind of create two levels of cutting for different resolutions. Wire cutting for the rough cut and a heated scoop for the fine cut. Unlike traditional CNC milling, this resulted in a product that could be reproduced much faster. And so here we see the wire cutting of a rough silhouette. Again, very studenty, unpolished. But this is a kind of extremely efficient method for cutting that can be used on stone if you would use an abrasive wire instead of a heated wire. Each piece took 3 minutes for the rough cut, and then a bit longer for the second round of cutting. But again, it's because we're using a heated tool rather than a mill, it could be done much faster. Okay, but the studio culminated in a kind of public exhibition in upstate New York. This was opening night. Stefan in the foreground. Okay, here's a project from another group in the same studio. This time they were sampling Corinthian columns. Huh? Oh, never mind. Okay. It's a video. It's this one. It doesn't. I think because you press next, so it doesn't do it anymore. Doesn't matter. We can skip it. Again, looking at systems of aggregation and part-to-whole relationships. What?
Chaos. And this is.
Oh, okay.
Yeah, there we
All
go.
right. Yeah, so here they were looking at overlapping kind of Trouchet patterns, so that at different scales that would interconnect and loop together. So on the one hand, we had the kind of system for aggregation, and then on the other hand, we have the sort of small local articulation. So again, I think the inscription of the machine path in this project, like many of the others, is more desirable than the fidelity of the geometry. Another topic, just to end this, another topic we are also examining in our teaching is the relationship between architecture, film, media, and AI. So this series of studios is called Gateways, and this was a studio we ran in the US, and we also ran it as a design build at INDA back in 2020, was it? Yeah. This particular image is from our US studio, and this is from our INDA design build. The idea was to design kind of machine-readable architecture surfaces that could act as trackers for augmented reality. And it is kind of an exploration of a kind of cyborg architecture, where a kind of digital veneer is superimposed onto the physical architecture. So this is a kind of similar project. This is a thesis student of mine working with AI convolutional neural net style transfer. So in this type of AI constructs the kind of general content and form with one image using the style and local details of another image. And here the AI is kind of fed two images or two data sets. The first data set is the facade, and the second data set is kind of image, in this case, of a traditional Chinese ceramic work. And then I guess various image to geometry techniques were used to superimpose this back onto the facade. And again, I think I would say that this is another take on smallness, craft, and locality. Does craft necessarily need to be physical? Can it be phygital or a kind of digital physical hybrid? Can the generic be confronted through the superimposition of media tectonics? Here with the AI, we were interested in the kind of uncanny quality of the expression, and again, not in pastiche. So the idea as well, I think with this particular project that the student did, was that, it's a kind of architecture that's suspended in time. And we're confronted with a piece of, an architectural artifact where both historical and neoteric expressions kind of exist simultaneously. All right, so I'm gonna end here and open up the floor for questions. Thank you.
Cool. Thank you, Stefan and Hseng. And yeah, so we're going to open the floor for questions if anyone has any. I can also maybe kick off with a question. I think actually I got asked this question a while back, and it was kind of interesting. It's kind of focusing on the robots. So the question was is the robot like a machine, a tool, a collaborator, or like something else? So I'm wondering, because your work is so entangled with the robots, with a tool, with algorithms, how do you see these as sort of collaborators or
Well, we're on the way to have students hand carve. We're just not there yet. So it's sort of you give we're using software to shortcut the hard labor of making, kind of, you could argue, but it's not that easy, of course. But I don't know if that answers your question, but
No, I guess it's like
I guess I would say in its current state, it's just a tool.
Hmm.
And I mean, like all tools, it comes with a certain imprint of the machine. In this case, we're looking at the extrusion comes with a certain expression. The kind of carving comes with a certain expression. So the tool path very much becomes part of the expression. But yeah, it's very much just a tool in its current state.
Any questions?
Hi, thanks for the thanks for the talk. Loved it all. I was wondering how, when you're sort of planning out projects, you think about this line between what you can do and what you can't do in terms of sort of what's possible, what can only exist on a drawing, what someone will let you make. All the work is kind of right on that edge. And when you're sort of thinking through ideas, like, do you have that discussion about, should we make this thing real? Should we make this thing fake?
Yeah, it's a very good question. I think these days, if you look at the small and the crafty bit, it's, when is it real and when is it fake? Maybe that's something that this is a struggle of ours a little bit. How we would, it's the same thing that when we make an ornate piece out of styrofoam, it contradicts itself. We would be happy to, use stone blocks or wood directly, but it often has to do with resources and accessibility, the labs themselves. So there is very few places that has, all the resources to be able to do exactly what you're trying to achieve. So you might have to partner up with certain companies that can do these sort of things. Some of the expertise you might need as well, whether you're recasting or. But yeah, some of it becomes kind of a dance between real and fake, if you will. So maybe everything is fake at first, and then with time, it kind of finds a root. Do you have any?
I think it's a very well pointed question, actually. It depends. I guess there's varying levels of fakeness. Do you mean the fake copy or the fake or the
maybe fake was the wrong word, but for example, yes, it's about what you can do and someone who ideally you would make everything.
Yeah.
Because we're architects, but you would probably accept that there's value in exploring urban ideas that you would never be able to make as two people, but you would still want to get that idea out there.
Yeah.
So maybe it's less about fakeness, but just about literally,
feasibility.
Sure. Well,
Sure.
everything. Yeah. However you see the problem.
Yeah. I guess that goes back to our conundrum, because on the one hand, we have these sort of extremely large scale corporate projects, and it's very difficult to have the kind of agency with materiality that we, in that context, that we would have when we do kind of this more research-based with a more research-based work. But I think, oddly enough, the tools that we use, we didn't talk about it in the corporate work so much, but the tools are not so different. Even the corporate work, it's like all the kind of offsetting, the site zoning, like that's actually been done algorithmically by us. That's why we're able to do such a large urban plan with only 2 people. So I think if you would kind of break it down as a kind of systems-based approach, like even the kind of shear walls between buildings, like all that is algorithmically produced. So if we would break that down kind of one step further, you could potentially also be able to apply kind of methods of 3D printing or whatever. But I think we just haven't been in a spot where we've been able or given the opportunity to do so yet. But yeah, I think potentially possible.
Yeah.
Yeah.
Thanks.
Hi, I really appreciate your 3D printing work, that you have an idea of how to print out a column without having supports, because when you do 3D printing, normally they have supports everywhere and it takes up material and it's not very ecology. You have to clean it after that. But then you can print up with a limitation, like 40 degree that you have said. You've said that you have to have not too much overhang. Do you think that's also a limitation to how you create the work?
Yeah, definitely. I think when you're working so closely with tools, and often the tool really dictates what you can and cannot do.
But also the robot, there is a degree of freedom that can, maybe it doesn't have to print up like this.
Yes.
But
Actually, one project we didn't show here is you can start to print overhangs if you move the robot, if you move the extrusion plane. So rather than printing this way, you can kind of arch the print. So we actually recently did a studio project in Sweden where we worked with this sort of non-linear printing. But again, you're kind of limited by this sort of spiraling, like one unidirectional print.
thank you.
Any more questions? Oh, okay.
Thank you so much for your presentation. I actually have two questions. The first one is, you did a few student projects that are led in both Ida and also abroad. And I'm kind of wondering about the universality of your projects. Like, are they applicable for any type of schooling? Is there differences between things that you kind of worked on here versus elsewhere? And then the second question is, what are you currently kind of interested in and what are you working on right now? Like, what's your areas of research that you are thinking of exploring?
Okay. I think if we compare the two schooling contexts, I think the same things are allowable, it's just under different systems. So what you would call a vertical studio here we have it as a kind of year 4 options studio. So I think there's a difference in the sense that what's helpful, the vertical studio allows the kind of cross teaching between year groups. So it allows the kind of older years to almost babysit the younger years. And there's a kind of learning, there's an opportunity in learning there that I find quite helpful. Which I think doesn't occur here right now because everyone who does the kind of option studio is within the same year group. Interestingly enough, in these settings, the younger years actually often do the best in the verticals. In that particular school, the third years always outperform the fifth years, even though they came in with less knowledge. Yeah. And what are we working? Did you want to add? What are we working on right now?
I think when it comes to the two courses you might refer to, I think there was a design build summer course we did, if I don't recall wrong, and we also did a similar summer thing in the States. So I think in this case they were quite similar, even though there was a different range of students, I guess. Yeah.
So, the output was completely similar.
Well, they were quite. There were differences. One, the one here was we focused more on the media bits, I think, and on actually the fabrication too, because in Bangkok it's so fantastic because we can go to Bangsi, if I pronounce it right, and sort of we can use the students can, instead of doing everything themselves, let's say, you have the opportunity to have students function as, they communicate with someone using CNC rather than doing it themselves a little bit. So we can cover quite a lot of ground here quite quickly, which is very exciting. Sorry, Nice, I forgot the second question.
What are you working on right now?
Oh, yeah. So I think, we are, these three things, sort of, the developer work and the robotics and the media-related Then there's a couple of other things, but that's essentially that's our clusters, and then things sort of spin off of that. Yeah. I hope that answered it.
Any more questions? Cool. Well, thank you very much, Stefan and Hseng. If you haven't got any more questions, we can. One, was that? Oh, a clapping. Okay. I think we can give a big applause to Stefan and Hseng.
Thank you so much.